Black holes form when massive stars, often over 20 times the sun's mass, exhaust their fuel and collapse under gravity. The core compresses into a singularity, where matter is crushed into infinite density, surrounded by the event horizon, beyond which nothing, not even light, can escape, rendering black holes invisible to direct observation. They are detected by their bending of light or the violent behavior of matter spiraling in. A process called spaghettification makes black holes particularly terrifying. If you fell toward one, tidal forces would stretch you into taffy until torn apart atom by atom, long before crossing the event horizon. Black holes are dynamic. Some drift through space as cosmic predators. In 2023, astronomers observed a supermassive black hole, about 20 million solar masses, moving faster than 4,500 times the speed of sound, leaving a trail of newborn stars over 200,000 light-years, formed from gas compressed during its passage. It was likely ejected during a galaxy merger. Black holes don't consume matter quietly. Infalling gas forms an accretion disk that heats to millions of degrees, emitting X-rays and gamma rays. Some launch jets of relativistic particles that outshine entire galaxies and extend for millions of light-years, flooding space with lethal radiation. Millions of rogue black holes likely drift unseen through the galaxy, invisible until something comes too close. Gamma-ray bursts are the brightest electromagnetic explosions in the universe, releasing more energy in a few seconds than the sun will emit over 10 billion years. They occur when massive stars collapse into black holes or when two neutron stars merge. Unlike ordinary explosions, gamma-ray bursts are directional, firing narrow beams of radiation at nearly the speed of light. If a gamma-ray burst pointed at Earth from within our galaxy or a nearby one, the consequences would be catastrophic. The initial flash would vaporize our ozone layer within seconds, exposing the surface to lethal ultraviolet radiation, which would cause mass extinctions, collapse photosynthesis, and unravel the food chain. Most complex life would be gone within weeks, and we would have no warning since light and gamma rays travel at the same speed. Some scientists think a gamma-ray burst may have triggered the late Ordovician mass extinction around 440 to 450 million years ago, when about 85% of marine species disappeared. If one occurred within 6,000 to 6,500 light-years, the radiation could have stripped the ozone layer and irradiated the surface for years. While speculative, this hypothesis is physically plausible given their lethality. Although space telescopes detect gamma-ray bursts nearly daily, they originate from distant galaxies billions of light-years away. The likelihood of one occurring nearby and pointing at us is low, but not zero. Somewhere in the Milky Way, a massive star is nearing death, and if its collapse results in a jet aimed our way, extinction could arrive at the speed of light. The Boötes Void is an enormous region of space about 330 million light-years across that contains almost nothing. Discovered in the early 1980s, this super void holds only a few dozen galaxies, whereas cosmological models predict it should contain thousands. If the Milky Way were placed at the center of the Boötes Void, observers on Earth would see almost no other galaxies in the sky, only darkness stretching in every direction. Voids form naturally as the universe evolves. Gravity pulls matter into dense clusters and filaments, leaving behind regions that become emptier. But the Boötes Void is so large and underdense that it challenges standard models of cosmic structure formation. What makes the Boötes Void psychologically unsettling is its visibility. Black holes terrify because they are invisible. The void terrifies because it is too visible, a gaping absence where something should exist. Galaxies inside the void are late-type, gas-rich spirals that evolve slowly due to lack of gravitational interactions and collisions that drive star formation elsewhere. They are isolated islands in an ocean of emptiness, drifting through a cosmic desert with no neighbors. Standing on a planet inside the Boötes Void, the night sky would be almost featureless. No spiral arms, no clusters, no distant galaxy glow, just darkness. The void proves the universe is not uniformly filled, that vast stretches of space exist where matter simply chose not to gather. It reminds us that the cosmos operates on scales and timescales indifferent to observers. Not all planets orbit stars. Rogue planets are worlds ejected from their solar systems, flung into interstellar or intergalactic space by gravitational interactions. They drift alone through darkness, frozen and starless like cosmic ghosts. Astronomers estimate there may be more rogue planets than stars in the Milky Way, potentially billions of Earth-sized worlds wandering invisibly through the void. Rogue planets are nearly impossible to detect because they emit no light of their own. Occasionally, one will pass in front of a background star, briefly magnifying its light through a process called gravitational microlensing. But these events are rare. Most rogues remain undetected, invisible until they drift too close to something we can see. One could be approaching our solar system right now, and we would not know until it arrived. In 2023, the James Webb Space Telescope detected over 500 free-floating Jupiter mass objects in the Orion Nebula, including roughly 80 binary pairs orbiting each other. These objects, called jumbos, are not planets in the traditional sense because they did not form around a star. They condense directly from gas clouds, yet they are too small to ignite fusion and become stars themselves. They exist in a gray zone between planet and brown dwarf, and their abundance suggests that planet formation is far more chaotic and diverse than models predicted. The universe is littered with these wandering horror stories, and we have no way to track them. When a massive star dies, it can collapse into a neutron star, an object so dense that a teaspoon of its material would weigh about 1 billion tons. Neutron stars pack the mass of the sun into a sphere roughly the size of Manhattan, about 20 kilometers across. They are the universe's densest stable objects, composed nearly entirely of neutrons at nuclear density. Neutron stars spin at incredible speeds, sometimes hundreds of times per second. As they rotate, they emit beams of radiation from their magnetic poles, creating pulsars that sweep across space like cosmic lighthouses. If such a beam pointed at Earth, it could sterilize large surface areas. Some, called magnetars, have magnetic fields trillions of times stronger than Earth's. Approaching within 1,000 kilometers of a magnetar would rip electrons out of your atoms, disintegrating you before reaching the surface. When two neutron stars collide, they produce some of the universe's most violent events. The collision creates gravitational waves, ripples in space-time, detected first in 2017. These mergers forge heavy elements like gold, platinum, and uranium through rapid neutron capture. Magnetars are the universe's strongest magnets. SGR0501 plus 4516 is an ultra-magnetized neutron star at the Milky Way's edge that defies usual formation models. Using Hubble and Gaia data, astronomers found it did not form in the nearby supernova remnant, once thought to be its birthplace. Its origin remains unknown, indicating magnetar formation channels we do not yet understand. Neutron stars prove size isn't a danger measure. They are compact, dense, and capable of annihilating anything that approaches. The Milky Way is not a calm, static disk. Extending roughly 25,000 light-years above and below the galactic center are two massive lobes of gamma-ray emission called the Fermi Bubbles. First clearly mapped by the Fermi Gamma-Ray Space Telescope, these structures resemble an hourglass of high-energy radiation framing our galaxy. The leading hypothesis is that the bubbles resulted from a past outburst of Sagittarius A star, the supermassive black hole at the galactic center. A few million years ago, the black hole likely experienced a brief but intense feeding episode, consuming a large amount of gas and launching powerful jets of radiation and particles into intergalactic space. The energy required to create the Fermi bubbles is equivalent to millions of supernovae, a staggering release that reshaped the structure of the galaxy. What makes this discovery unsettling is that it happened relatively recently on cosmic timescales, and we are living inside its aftermath. Our galaxy is not peaceful. It is a system that periodically erupts in violence, driven by the feeding habits of a 4 million solar mass black hole lurking at its core. Few people outside astronomy know that we are sitting inside the calmer remnants of a past galactic catastrophe. The Fermi bubbles are invisible to the naked eye, detectable only in gamma-ray wavelengths, but they frame our existence. They are a reminder that even our home galaxy has a violent side capable of flooding tens of thousands of light-years with lethal radiation. Fast radio bursts are millisecond duration spikes of radio emission originating from extreme distances, often billions of light-years away. A single burst can release as much energy in a few milliseconds as the sun emits in days. Most are one-off events, though some repeat irregularly. The physical origins are still debated, but the leading candidates are magnetars, highly magnetized neutron stars that occasionally release bursts of energy as their crusts fracture or as magnetic field lines reconnect. Even stranger are odd radio circles, or ORCs. These are ring-shaped structures spanning roughly 1 million light-years that emit only in radio wavelengths and have no visible optical counterpart. Discovered in 2019 using the Australian Square Kilometre Array Pathfinder, ORCs do not correspond to any known class of object. They may be shock fronts from ancient supermassive black hole mergers or galaxy collisions, but their origin remains uncertain. Only a handful have been detected, and each one challenges existing models of cosmic structure. What makes these phenomena terrifying is not their immediate lethality, but the fact that they reveal a sky full of unseen agents. The universe is crackling with explosive engines, macro-scale shockwaves, and transient events we can barely classify. Fast radio bursts arrive without warning. We are detecting these phenomena at the edge of our technological capability, which means we are likely missing countless others. The radio sky is a hidden layer of reality, pulsing with signals we are only beginning to decode. Each new detection opens more questions than it answers. These phenomena are not science fiction. They are real, documented, and poorly understood, which makes them deeply unsettling. About 68% of the universe's energy density is dark energy, a mysterious entity causing the expansion of space to accelerate. Observations of Type 1a supernovae, baryon acoustic oscillations, and the cosmic microwave background all confirm that galaxies outside our local group are receding faster and faster. If dark energy behaves like Einstein's cosmological constant, this acceleration will continue indefinitely. The long-term consequences are bleak. Within a few 100 billion years, galaxies beyond our local cluster will move away so fast that their light will no longer reach us. Observers in the distant future will look out and see only the stars of their own galaxy, surrounded by darkness. The cosmic microwave background, the afterglow of the Big Bang, will redshift into invisibility. Future civilizations will have no evidence that the universe was ever larger or more populated. They will think they live in a small, isolated island of stars, in an infinite void. In some models, if dark energy's strength increases over time, it could eventually tear apart galaxies, stars, planets, and even atoms in a scenario called the Big Rip. This is not science fiction. It is a mathematically allowed future trajectory consistent with current observations. The timeline for such an event would be tens of billions of years, but the fact that it is physically possible makes the universe feel less like a hospitable home and more like a slowly tightening trap. Dark energy is the most abundant form of energy in the cosmos, yet we do not know what it is. We cannot touch it, see it, or interact with it directly. We only know it exists because galaxies are accelerating away from us. The universe is not just expanding, it is accelerating its own dissolution, driven by a force we cannot explain. Even in the apparent emptiness of space, the universe is hostile. Interstellar and intergalactic space is filled with cosmic rays, high-energy protons and atomic nuclei accelerated by supernova remnants, active galactic nuclei, and other violent events. These particles travel at nearly the speed of light and can penetrate spacecraft shielding, flesh, and bone. Long-term exposure shreds DNA, increases cancer risk, and can damage the nervous system. Earth is shielded by its magnetic field, which deflects most cosmic rays and traps them in the Van Allen radiation belts. This invisible umbrella is the only reason complex life can exist on the surface. Step outside that protection, such as on a long mission to Mars or in deep space, and radiation becomes a constant invisible threat. Beyond cosmic rays, space is filled with diffuse gamma-ray and X-ray backgrounds, the unresolved glow from distant gamma-ray bursts, active galaxies, and accretion events. This radiation permeates supposedly empty volumes, meaning that even far from obvious catastrophic events, matter is slowly eroded by the cumulative energy of an active cosmos. Our sun also poses a radiation threat. Solar flares, bursts of radiation from the sun's surface, can fry satellites, knock out power grids, and expose astronauts to lethal doses of radiation. In 1859, the Carrington event sent massive solar flares into Earth, sparking telegraph lines and electrocuting operators. If the same event occurred today, it could disable the internet, shut down global communications, and cause trillions in damage. Space does not need exotic monsters to kill us. Sometimes our own star is enough. In a deep background image captured by the James Webb Space Telescope of the star-forming region Herbig-Haro 46/47, astronomers found something unexpected. A distant plume of hot gas perfectly shaped like a question mark, glowing faintly in infrared wavelengths. Its origin is currently unknown. It could be a pair of interacting galaxies viewed edge-on or a single galaxy with unusual morphology, but no definitive explanation has been confirmed. This small, curious object encapsulates a larger truth about the cosmos. The universe is littered with patterns that feel almost intentional, yet are produced by impersonal physics. Nuclear pasta and neutron star crusts. Bizarre arrangements of matter under extreme pressure. The cold spot in the cosmic microwave background, a patch colder than expected that some speculate could be a signature of a collision with another universe. The Eridanus supervoid, a massive underdense region that correlates with the cold spot and defies easy explanation. These phenomena are not dangerous in the way black holes or gamma-ray bursts are dangerous. They are unsettling because they reveal how much we do not know. Every deep survey, Every new telescope uncovers more objects and structures that do not fit existing models. The universe is stranger than our theories predicted, and each answer raises new questions. The question mark nebula is a fitting symbol for the state of cosmology. We have mapped the large-scale structure of the universe, detected gravitational waves, and photographed the shadow of a black hole. Yet the cosmos remains fundamentally mysterious. Dark matter, dark energy, fast radio bursts, rogue planets, and wandering black holes all remind us that we are observers in a universe we barely comprehend. If you want to keep exploring the strange and terrifying edges of science, subscribe and check out this video next. Thanks for watching.